Hi everyone, we are back with lesson number 3. We're sticking with our exponential functions and a lot of practice today, just rewriting expressions with those fractional exponents and negative exponents. So the first thing I want to do is just give you guys those rules right on top so you can practice and remember. First thing I want to talk to you about are negative exponents, okay? Negative exponents. So make little notes for yourself that when you see a negative exponent, all you're doing is taking the reciprocal of the base. Okay, when you take the reciprocal of the base. Okay, what does that do? It makes your exponent become positive. For example, if you have x to the negative 2 power, technically that's over 1. So when you take the reciprocal, it becomes 1 over x, and that immediately makes that exponent positive 2. Okay, the other thing I want to talk to you about is fractional exponents. Okay, so let's talk about fractional exponents. If I give you, I don't know, let's just say a base of 2, and I raise it to the 3 over 4 power, remember, that's power over the root. Okay, so there's 2 ways to write it. You could write that as the 4th root. Notice, look at where my 4 is. It's in the index. It's not a big 4 in front of the radical. It's in that little index there. It's in my thing. My base of 2 to the 3rd power. Okay, you could write it like that. The other way that is perfectly acceptable for you to write it, and you're going to see it, is the 4th root of 2 and that whole thing raised to the 3rd power. Okay, so I just want you to be aware of both of those. Okay, so pretty much throughout the lesson, you guys can like try on your own, then pause me, check your answers, and so on and so forth. Okay, so let's just take a look at the first one. If you have f of x equals x to the negative first, plus 2x to the negative first, and they want you to find f of 3. So they're just giving you a basic function, and they're asking you to do f of 3. That just means wherever you see an x, you're going to plug in a 3. So that means f of 3 equals 3 to the negative 1 plus 2 times 3 to the negative 1. Okay, so we got a lot of operations, a lot of negative exponents, but let's just talk this first one. 3 to the negative first power is literally 1 over 3, technically to the first power, which is just 1/3. And here, 2 times 3, you're going to simplify inside parentheses before you do your negative exponent, because that whole thing, 2x, is being raised to the negative 1. So that is 6 to the negative first power. So I'm going to bring it back up here. So f of 3 is going to be 1/3 plus 6 to the negative 1 is 1/6. Okay, you can go right to the calculator, right? You don't need to go crazy and be finding common denominators and stuff. Literally do 1 divided by 3 plus 1 divided by 6, and there's your answer, a half. Okay, so there's your answer, 1/2. Okay, so there's some negative exponents. Okay, let's talk about number 2. Important. You have negative exponents all over the place. I think the easiest way for you to do this is to rewrite anything that has a negative exponent. Now, I want you to take note, this 2 in front and this 4 in front, right? they are not raised to the negative exponent. They should stay exactly where they are. So this fraction, okay, the 2 and the 4 stick to where they are. Now look at the x to the negative 2 and y to the negative 2. Both of these in the top. I'm going to make them orange. They're both negative. So where are they going to be positive? In the denominator. I'm going to make x become x squared down in the denominator and y to the negative 2 become y squared down in the denominator. Because when they are negative, drop them to the denominator, automatically positive. Now, in the reverse, here you have y to the negative 5th in the numerator. I'm sorry, in the denominator. Bring it up to the numerator, and that's going to become positive. So now you have y to the positive 5th up top. Now, what can we simplify? If you look up at the top, the 2 and the 4 can be simplified. 2/4 is not even 1. That's a half. So this is going to simplify to where this is a 1 and this is a 2, which means I don't need the 1, but there's definitely a 2 in my denominator. Okay. Your x squared has nothing to simplify with. Leave it where it is. But look at these two. You have x to the 5th and y to the 2nd. There is a quotient rule where you keep your exponent, you keep your base and you subtract your exponents. And if you do 5 minus 2, you get y to the 3rd, and it's positive, so it stays in the numerator. So that should be the answer you're looking for, which is choice 1. Okay. All right, let's practice another one. It's going to be easier, and it's going to test you on all your different rules. So this looks so just a little weird, right? Prove the following. We're going to start doing a proof. No, it's not as bad as you think. First of all, when you're proving, you really only have to work on one side. So I think this one is easier to work with, okay? And notice what you have. You have, okay, make a little note for yourself. This is power to a power. What does that mean? It means you have an exponent raised to another exponent. What does that mean? What rule? That means you're going to multiply your exponents. Okay, so that means you're going to have x to the 3/4 times 2. So now again, if you are not sure, go into that calculator, okay? I'll show you. If you need to multiply, you're going to do 3 divided by 4, and you're just going to multiply it by 2. So there's where you get 3/2. Okay, so that means, okay, so is this going to equal this? This is x to the 3/2. And it makes sense because it becomes 6/4, which simplifies to 3/2. Okay, well, what do we know about a fractional exponent? So I'm going to make my other rule. Fractional exponent, immediately you should be saying the rule power over root. So that means this is the square root, right? There's your root, which I don't need a number in, of x to the 3rd power, x cubed. Now, I kind of touched on this. We had done this a while ago, but we had touched on this in like 2 lessons ago, I think lesson 1. X to the 3rd power can be simplified. You want to figure out in any even exponent. So I'm going to make a little note. Even exponents are perfect squares. Okay, so the biggest perfect square that can go into x to the 3rd, I'm going to break it down. Remember this? Okay, so I'm just following along that whole right side. But I could break down x cubed into x squared and x. X squared times x is x cubed, and x squared is the biggest perfect square that goes into it. What's the square root of x? X. Rad x, and there is your proof perfectly done. Okay. All right, a lot of work, but if you know those few rules, you're going to be in good shape. Okay, let's try another proof. Take a look at 4. Okay, so this is saying is 8 to the half raised to the third equal to the 6th root of 8. Okay, so this is like a little question mark. So you could do one of two things. You could work on one side or the other side. You could make 6th root of 8 back into a fractional exponent. You could work that way. Or you could take 8 to the 1/2 to the 1/3 and try to work it back into a radical form. So I'm going to work with this side, but you could do whatever one you want. To me, again, I immediately see power to a power. Okay, so I'm going to multiply. I'm going to say 8 to the 1/2 times 1/3. Will that give me the 6th root of 8? Well, if I multiply, I get 1 times 1 is 1, 2 times 3 is 6. Okay, so now can I convert 8 to the 1/6 into radical form? Remember, power over the root. So it's the 6th root of 8, technically to the first power, which is exactly what we have. So it's not as bad as you think. I know it looks intimidating. It's not as bad as you think. Okay, let's go to the next one. Lots of words, lots of expressions. Try not to get confused. So let's talk about number 5. They tell you if x is greater than 0, okay, and m, here's your first really important piece of information. M is positive. So why are they saying that to you? Well, that means that your exponent is positive. If it's 3 over a positive number, then it's going to be a positive answer. If that means, okay, so I'm going to make a little note. Your exponent is positive, okay? Then circle which of the following expressions are equivalent to 5x to the, now that whole 5x is being raised to the 3 over m. So remember, here's your power, here's your root. Okay, so couple of things. I see some of these down here that would never, ever, ever be your answer if we're talking about positive. So I'm hoping you all can see anything with 1 over, like this guy, and this guy, and this guy, and this guy. That's never going to be your answer. That's when, if you notice down on the bottom, you have a negative exponent, not a positive exponent. So if I convert this to power over root, now again, I want to make this very clear to you. This entire 5x is being raised to the power over root. So that means the m root of 5x to the 3rd power. So do we see that as one of our choices? Yeah, it's that first choice right there. This, no doubt, it says circle. I guess I should be circling. That is definitely one of the answers. Now, is there any other way I could potentially simplify this to see if I get another one of these answers? We already said this second one to the right, no way. But look at the next one. The mth root, okay, that's true, of 125x to the 3rd. Well, is there any way I could simplify 5x to the 3rd and it become 125x to the 3rd? Yeah. If I write this out, this guy right here, okay, if I write this out 5x 3 times, guess what I get? I get this can be simplified to the mth root of 125x cubed. So this is also correct, a choice I'm circling. Okay, so we know it can't be the 1 over, it can't be the 1 over. Now, this next one that we come to, that's not a 1 over. This guy right here is really important. A lot of kids will say, oh, that's the same thing, 5x to the 3rd. But what is the major difference? What is this missing? There are no parentheses. So it's wrong. Could never be. It's missing that. Since it doesn't have that, I'm not going to leave it there. I'm going to cross it out. That could never be your answer. So you have one more, because this guy's 1 over, so it can't be that one. Look at this one. Is the last one in here, the mth root of 5x to the third power, also acceptable? Yes. Oh, this is another one of your answers. That's just the other way to write it, with the whole entire thing in parentheses. So that's perfect. Okay, so let's just talk the other way. If x is greater than 0 and m is now negative. So if m is now negative, now you're talking about a negative exponent. So it's all the ones we left out, right? With the 1 over, let's check those. So let's look at that first one I come to. 1 over the mth root of 5x to the third power. Yeah, that one would be good. 1 over the mth root. This one doesn't have parentheses, but it's taking that whole 5x and it's raising the whole thing to the third power. So this one would be good down on the bottom. Good. How about that next one we come to up top, the last one up top? 1 over the mth root of 5x cubed. Okay, hopefully you're all saying no. This one is like the other one I crossed out. There's no parentheses. So it's only raising the x to the third power, not the 5 to the third power. The next one we come to looks good. 1 over the mth root of 125x cubed. Yup, that's going to work. And the last one is also good. 1 over the mth root of that whole 5x. That whole thing is being raised to the third power. So we're in good shape. Okay, so that was a tough one. All right. I'm going to keep going with 6. Okay, so in number 6, be careful. You not only have a fractional exponent, it's actually negative. So I'm just going to rewrite this. This is 9x squared y to the 6th being raised to the negative 1/2. So you're looking at, again, I'm going to remind you, negative exponent. In order to make a negative exponent positive, all you're going to do is take the reciprocal of the base. Take reciprocal of base. Okay, so that's going to automatically make your exponent positive. Here's the base. The base is this entire 9x squared y to the 6th. 1 over 9x squared y to the 6th. I just took its reciprocal. Now what does that do? It raises it to the positive 1/2 power. Now it still looks terrible, but the 1/2 power, remember, is the power over the root. So technically this is the square root of 1 over 9x squared y to the 6th. They're all perfect squares. What's the square root of 1? 1. What's the square root of 9? 3. Out of the radical. What's the square root of x squared? X. What's the square root of y to the 6th? Y to the 3rd. So that is your answer. You know what? I'm not going to do, it looks too confusing. I'm going to just use, this is your final answer. 1 over 3xy cubed. So go back and check. This was multiple choice. Choice 1 is your answer. Okay. I'm going to 7. So 7 says, use all your properties of rational exponents to determine the value for y. Okay, this was a Regents question a few years ago. It looks, again, super intimidating. And what are they asking you to find? Determine the value of y. Look at what y is. Y is just the exponent. That's all they want. Find value of the exponent. Now, they give you all this other information. They tell you, okay, they give you the whole expression, the 4th root of x to the 9th over x to the 1/4 to the 3rd. Find the value of y equals something to the y, x to the y. And then they say, oh, when x is greater than 1. All right, don't even worry about that, okay? You really care about just taking this expression right here, okay, and simplifying it to a base of x with an exponent of y to figure out what the value of y is. So now you got rules all over the place. Convert this. This is right now in radical form. Let's convert it to a rational exponent by using power and root. So it's the base of x. What's the power? 9. The root 4. Done. In 2 seconds, you take that and turn it into power and root. Okay. Now, denominator. Check that out. Power to a power. Again, power to a power. Multiply your exponents. So technically that's 3 over 1. So 1 times 3 is 3 in the numerator. 4 times 1 is 4. Okay. So again, that's got to equal x to a power of y. Well, now look what you're looking at. This is just the quotient rule. What does the quotient rule tell you? Subtract your exponents. So you're going to keep your base and you're going to do 9/4 minus 3/4. Okay, so nice. This has the same base, right? The same denominator. So you keep your denominator and you do 9 minus 3, which is 6/4. So I think if you wrote 6/4, you would be super close to getting the right answer because that's what they're looking for. What's the exponent? But understand, 6/4 can be simplified. It simplifies into 3 over 2, and that means that, look, 3/2 is y. Y equals 3 over 2. That's your final answer. Okay, that's your y value. Okay. This is your last couple of questions. Should I do them? I'll do them for you, and then I'm going to give you a little practice sheet. Okay, so many ways to do this. I think you should simplify inside your parentheses first, and then move on to do your other stuff. But like inside here, I see quotient rule. So keep your base, okay, x, subtract your exponents. 6 minus 2, and that's going to be raised to the 1/2 power. So you could then say, what is that going to turn into? X to the 4th to the 1/2. Now you could turn it into radical form, power over root, but this is also power to a power. 4 times 1/2 is 2, and you're done. X squared would be your answer. Okay. I'm going to do that next one. Now be careful. Okay, so this is a good one. I'm going to simplify what's in here first. Again, you have quotient rule. So if I subtracted exponents, keep my base, subtract 8 minus 2, 6. Keep my base of y, 4 minus 2, 2. And that's being raised to the negative 1/2 power. So a little bit more difficult. In order to get rid of that negative exponent, I'm going to take the reciprocal. So I'm going to make this 1 over x to the 6th y squared, okay? And now it's going to be raised to the positive 1/2 power. This 1 over 2, again, is power over the root, which means it's the square root of 1 over x to the 6th y squared. And they're all perfect squares. That becomes 1 over x cubed y, and this is your answer. And this was your answer to the first one. Okay, I'm going to do the next one. In the next one, you have, again, you're going to do x squared minus 1/2. Everybody agrees? And you're going to raise it to the negative 1/4 power. So 2 minus 1/2. So I'm going to go into the calculator and I'm going to show you. If you do 2 minus 1 over 2, you get 3 over 2. I think the improper fraction is better to see. So that's going to give you x to the 3 over 2 raised to the negative 1/4. Now, you could do a couple of different things. I almost think it's easier for you to maybe multiply first. So if that's power to a power, you would get x to the negative 3 over 6. Okay, because you multiply 3 times negative 1, 2 times 4. Numerator times numerator, denominator times denominator. Well, negative 3/6 becomes x to the negative 1/2. How am I going to make that positive? Make it 1 over x to the half, which becomes 1 over this, you could say 1 over the square root of x. And that would be your final answer. Okay, last one. This is a good question. Another Regents question from a few years ago on A2. If you are going to rewrite, right, this, you're going to take radical form, okay, and you're going to convert it back into rational exponents, which means you need to do power over root. Okay, so you actually have to do it with the coefficient too. What is 8's exponent? 1. So you're going to raise 8 to the power of 1 over the root of 3. You're going to raise a to the power of 4 over the root of 3. You're going to raise b to the power of 5 over the root of 3. Now, if you look at this, 8 to the 1/3, 8 to the 4/3, you don't see it because I'm just going to go here and show you that 8 to the 1/3, if you raise 8 to the 1/3 power, look what you get, 2. And it makes sense because it's the cubed root of 8. So it's 2, a to the 4/3, and b to the 5/3.
I called Connor.
You called Connor?
Yeah, and he's still on the phone.
He is?
Yeah.
Okay.
Yeah, with Landon.
Do you want to say hi to my kids? Say hi.
Can I have a loose sip of that?
Yeah, you can have my coffee. All right, I gotta go. Lucy's right here. Okay, so 2, a to the 4/3, b to the 5/3. Here's your answer right here. Okay, love you guys, miss you guys. I'm gonna give you a little practice. This is not easy, so practice with the sheet. I'll talk to you soon.